Good morning, students. Now in this video we will learn about the fourth application of dimensional formula, and the fourth one is to create the relation between other physical quantities. This is the one of the fourth application of dimensional formula. So I am going to start with an example. Let suppose there is a pendulum, and the oscillation of the pendulum, it starts when we apply some force into it, right? And the time period of the oscillation depends on some factors. Let's suppose its time period depends on the length of this string. It depends on the mass of this oscillating bob and the gravity, right? So the time period depends on the L, depends on the M, and depends on the G. But we don't know whether it is dependent over only the length L to the power 1 or L to the power 2. So we don't know what is the powers of L, M and the G. So I can write, let's suppose its power is A, its power is B and its power is C, right? And if we remove this proportional sign, I have to write one constant called K, L to the power A, M to the power B and G to the power C. This is called the oscillations constant. The time period constant comes in this oscillation, and after completing one round, so it makes angle about 2 pi. So we can take K as 2 pi later on. Okay. This is called the equation number first. Now what we have to do? You can see there is the length, mass and gravity, and this is called the time period. Then we will convert these all quantities into their dimensional formula. So I am going to convert the T as the time period. So I will write like T and its power is 1, that is equal to K L to the power A, right? I have what I have did? Conversion of quantities in dimensional formula. So if you are listening, you can note it down. And L is the length, then L to the power A, M is the mass, then capital M to the power, I can write here also, B, and G is called the acceleration due to gravity. As acceleration has dimensional formula L T inverse 2, so we have to write here L T inverse 2 to the power C. Okay, so this is T to the power 1, this is K L to the power A, and this is M to the power B. This is, if you are opening the bracket, then you can write L to the power C, T to the power minus 2C. Okay, now you can add the this power, the indices of the same basis. Then T K L to the power A plus C. There is no M, then I can write L to the power A plus C, M to the power B and T to the power minus 2C, right? Okay, so this is called your equation number 2. Now in this equation what we will do? After this we will do the comparison of the indices from left hand side to the right hand side with respect to their L, M and the T. As we know, there is no M, there is no L and there is no M and L. Okay, so I can write here M0, L0, T to the power 1. Okay, I have converted this, and this is equal to K L to the power A plus C, M to the power B, T to the power minus 2C. Okay, so the next is comparison of powers of MLT from both sides. Okay, so what you will do? Take the M here and M here. The power of M is B here and the power of M is 0. So we will write for capital M, the power 0 equal to the B. Yani one side the power is 0, another side the power is B. For L power is A plus C and there is no power of L. So we will write the 0 is equal to A plus C, or this equation C you can write A is equal to minus C. Right? For T, for T, the T to the power 1 is here and T to the power minus 2C. So for T, 1 equal to minus 2C, then C is equal to minus 1 upon 2. If the C is equal to minus 1 upon 2, then you can put and get the value of A. So here A is equal to plus 1 by 2. Now you got the value of A and B and C. Where the B is 0, A is equal to 1 by 2 positive and C is equal to minus 1 by 2. Now put it here in this equation number first. So I am going to put it. So this is called the T K L to the power A has value 1 by 2, M to the power has no value called 0, G to the power C is minus 1 by 2, M to the power 0, that means the time period doesn't depend on the mass. Then T is equal to K L to the power 1 by 2 and G to the power minus 1 by 2 you can write. Then L by G, no need to write the M this time, and whole power is 1 by 2, and if the whole power is 1 by 2, I can erase and I can draw a root. So I can write a root. Then T is equal to K under root L by G. So here the K can be as an angle, a unitless quantity. So K as a 2 pi. Let K as 2 pi. Then the T is equal to 2 pi under root L by G. So dear student, you must have seen that the time period doesn't depend on the mass. Earlier, I was taking that the time period depends on the mass, but after this, you can see this result. So this is called one of the application. You can do the next practice to create the relation amongst other physical quantities. Okay, note it down. Thank you.